Yeah, let's start with the embedded C programming. So, embedded C programming is usually meant for the embedded application for programming the microcontrollers. So, usually the C programming that we use to build an application at a higher level, we can even use it for programming a controller. So, a special type of the data types are used to, to define certain data types. We can customize it. So the memory is very crucial in case of programming certain controllers. So we focus more on that. So apart from that, the rest of the functionalities are going to be similar. Let's have a look into this. So data types used in the embedded C. So in C, we can find two types majorly, that is an integer data types and floating data types. So usually the numbers that are the whole number, the integers, so they are can be of different size now. So there are again varieties of data types under the integer one, and some of the computations are made on floating data types. So where the fractional numbers comes into picture. For example, if you are looking for some data which is of a fractional of 2-digit or 3-digit types, it depends on what is the precision that you're looking for. Uh, let's say 60.000001. So there are, I think, some 6 digits are kept for precisely giving 1 over some standards. So these are types of the floating data types. So, and if you categorize it still further in integer data types, there are again different varieties. So that can be considered as unsigned or maybe as a signed. It depends. So the integer data types are the signed numbers. So signed and unsigned numbers are treated separately in programming, especially for the controller. So whenever we deal with programming a microcontroller, so we should be aware of what type of data that we are handling. Is it a signed data type that are unsigned data types? So there are way to recognize the numbers. So in the signed numbers, where the number can be positive as well as negative, there are under character, int, shortened, long int, and long int. So if you look into the closer details of all these, like what is that character is. So character is usually 8-bit data. So and int is usually can be of 2 byte, or it can be 4 byte, or it can be 8 bytes sometime. It depends. We have to see the compiler that we are using and how it is organizing all these data types. And if you come to the unsigned integer, again the similar data types are there as what you see for the signed numbers. So the only difference in the signed arithmetics, so we should now if I take some example to define the signed numbers, so let me take up one example here. Okay. Let me take a screen. So for example, any number you take, anything like 8-bit number, if you consider, you know that an 8-bit number will be having the bits D0, D1, D2, D3, and D4, D5, D6, and D7. So this is the bits that I have. So I can actually have 0000 and 0000. This is in decimal is 0. Whereas if I put one more number in the binary, this is 1. The 2 is 0000, and I have here 0, 0, 1, 0. This is my 2. So on, if I am writing these numbers, it will go till 1, 1, 1, 1 and 1, 1, 1, 1. This is 255. So these are the possible range. Now the numbers between 0 to 255 is unsigned. This is what I call at unsigned. Now how do I take signed number? So I have a limited number of data bit, that is 8 bit, and my signed representation has to be including both positive as well as negative number. If I'm considering only the positive number, then it is an unsigned number that I'm considering. The range is pretty simple, like 0 to 255 that I'm going to get. So when it comes to signed number, so what they do is the MSP bit, the most significant bit is used for sign representation. It's used for the sign representation. That means if this MSB is 0, it is positive. If MSB is 1, then it is negative. That means you will get certain numbers, and finally after you get, so 0, 1, 1, 1, 1, 1, 1, somewhere you get. So this will be 7F, and possibly this is 127, and the next number starts 1000 and 0000, and so on it continues. So here it comes 8H, and which is nothing but 128. Now the interesting thing here is this number, okay, where you get 1000 and 0001 onwards, all these numbers are negative in signed. So what I mean to say here is anything between 00 to 7F is positive, because MSP is 1, 0. Okay, the MSP is 1. This is positive. And anything between 80 to FF is negative. It is negative. So let me go back again. 1 second. Yeah, my screen is here. So that's what the scenario. So we know that now 0, 0 to 7F, where MSB is 0, it is positive number, and 80 to FF is negative number. Okay. Now how do you know the 80 to FF? What is the value of this negative number? It is quite simple. So to know so 0 to 7F, it is quite straightforward. It is 0, 0 to 127. Whereas negative number, what is the value? Is it minus 128 to another minus 256? Then it is going to be wrong. If you say this is minus 128 to minus 255, then it cannot be a case, because then how do I represent the number minus 1 and minus 2, minus 3? How do I do it? So it's not possible. So I'm missing certain range. So what they do basically is we need to find out the 2's complement of this number. So take any of this number. Let's say I wanted to represent this 80, or any other number. You take it as 82. Let's take a number called 82. I wanted to find. So first write 82, 100 and 0010. This is 82. Takes the 2's complement. First take the 1's complement it becomes 0, 1, 1, 1 and 1, 1, 0, 1. Then add 1 to this, it becomes 2's complement. It is 1, 0, 1, 1, 1, 1, 1, 0. So this is the value of the negative number. So here it is, the value is 7e. Okay, 7e is the value. So 7e means the number is minus 126. So this number equivalent is 126. So that means the number here in signed number, remember, in signed value of 0x82 is minus 126. Now I can represent similarly FF if you take. What is the value of FF? It's quite simple. FF, you take 1's complement, it becomes 0, 0. Add 1 to this, it becomes 0, 1. So this is actually 2's complement you take. So you got 0, 1. What is that meaning? It is nothing but 1 only. That means minus 1. So I can represent here negative numbers from minus 127 to minus 1. That is the range of the negative number. So this is what we do in signed arithmetic. So this is applicable for even positive numbers. It is applicable for any length. It could be 8-bit or it could be 16-bit, 32-bit. Just remember the MSB bit, if it is 1, the number is negative, and to take the value of that number, take the 2's complement and get the magnitude in decimal format. That is going to be the negative value of that number, and positive value as it is in to take. So you are going to split the range. When the number is signed, the range will be split to both positive as well as negative half. So that one thing you need to remember. So now let's go back to the usage of these data types. The way to use the data types int. So there is nothing great in it. So you might have already used some of the data types in basic C programming. So there is a method to include the int variable. You need to declare it in the main function. So what I'm trying to do is, this program is pretty simple. So you included a standard stdio.h, which is a library that contains the definition of the printf statement, and I'm going to display it. Just I'll be using some straightaway and arithmetic operations in the printf statement, and I'm declaring an int variable now. So to begin with this, okay, just a practice. So let me show you. I'm going to use one of a simple compiler here. So what I will try to do here is I'm going to set up it in my Google Drive here. So I have my Google Drive. So what I'm going to do here is, so let me take you to the Google Drive, and in the Google Drive, so you have a program. So what I basically do here is I'm going to create a, in my Google account, I will go to one of the folder, and I'm going to install an application which is called as uh, the name is Code Compiler Editor. Okay, just search this Code Compiler Editor, please install it in our computer, and this drive can be this can be accessed using the Google Drive. So what you need to do is just go here and just make a right click and in any folder and just see Code Compiler Editor. The Code Compiler Editor will open now. So once the Code Compiler Editor opens, so you'll get a window something like this by default, which will be including with the stdio.h and so on. Now I'm going to say, for example, this is a program already here, and you need to compile it just by just clicking this, and you will see that the compilation is made depending on the speed, and you get to know what is going to be the hello world. That's what's going to get. So if you want to save this program, you can just use this option, save this file to my Google Drive. You can select a folder in the Google Drive and save it. That's how you can do all these things. So let me show you a simple program here which I already created. I created a prog1. I'm just going to open it with the drive here. 1 second. Okay. Let me go to the drive first. Compile editor, and let me open it from here. The one which I want to open prog1. Yes, here is the prog1. So what I basically did is I just declared a number 70 and another number 10. I'm just adding it and displaying it. So just check out the answer. So it's supposed to be 17, and here is the answer. Now this way you can actually now check some of the data types, okay, that I'm going to that. So let me take up to one of the program. So let me take to the code here, and so now let's look into this integer size and representation. So C has an integer type other than int, okay. So there are many long and short and so, and basically when we do some computation, so we do use the data types that are declared for for declaring a 2 byte or a 4 byte or a 8 byte data. Now it depends on what type of compiler that you are using. So integer could be a 16-bit sometime, or it could be even a 32-bit. Okay, so we need to define. So if you wanted to declare some number in a location, I say for example 255 want to declare. So it's up to you to see what is the range of the number that you are actually working on, and you just declare what should be your the preferred data type. Is it an int, or is it a long int, or is it a short int? That you need to decide, and then you're supposed to declare. And you can actually use an operator like size of operator, that is there for you to know what is the size of the data type that you're working on. So there are, apart from that, you have something called as ASCII. So anything that you put it in a quotes, it will be an ASCII equivalent. So 0 to F, any numbers that I have. So that's an ASCII table that we say, for example, if the number is 0, then the ASCII equivalent is 30. If number is 1, ASCII equivalent is 31. And 00 is null, 01 is SOH, STX. So all these are the shortcut keys, delete keys, and all these ASCII table you can just find, 7F is delete. Okay, so these are the ASCII equivalents. Now let's come to some of the data types of long, short, int data type. Let's check out what is that data type. So it depends. If you are working on a particular compiler, you can just find out what is the data type. So let me show how this program works. So what I suggest you is, in this example they are demonstrating long, short data types. As you can see here, the let me take to the pointers. Yes, if you look at this is a short int, a long int, and long int. So these are the 4 data types that are declared. So, and I'm going to show you what will be the memory, how many bytes of a memory and how many bits, obviously we can get to know with this kind of instructions, the printf statement I'm going to put it. So let me take you to the program where I'll be showing this for you. So let me take here, and I already have a program here. So let me open it with a code compiler editor. So yes, so here is the program. Okay, if you look into this, that will give an idea what exactly that we are doing. So I have a printf statement, size of shortened. So what I did here is percentage 1D, percentage 1D for bytes and bits. Okay, that's what defined two types of variables that I'm getting it from. Then what are this percentage 1? This is a single number. This is also single number, single digit, what I mean to say. And I use an operator size of a short int that gives the answer in byte. Okay, it gives the answer in bytes, number of bytes, so that many bytes will appear here. Similarly, for bits, you just multiply that with the 8 and you get the bits. So you know that 1 byte is nothing but 8 bits. Simply you need to multiply it by 8. So here is the data type for the a integer, a short int, a long int, a long int. Now, when you run this program, so let's see what happens when you run this program. So when you run this program, you need to run this here, and I should get my output at this point. Yes, I'm getting it here. Just look at this. So short int is 2 bytes, which is 16 bits, and int is 4 bytes here, which is 32 bit, and long int is 8, 64 bit. Long int is 8 byte, again same, it is 64 bit. There is no difference, it depends on the compiler. So you can actually choose the compiler that you wanted to work on, and you can actually use. For example, if I go for any other compiler, I think this will compile most of the code, like basics, assembly, C, GCC version, or many are there. I can compile it with any of this, doesn't matter. If you look at here again, it's going to be the same. I'm not finding any difference. Okay. So this way you can actually work on finding the data types. Now let's go back. So standard integers. So standard integers, if you are not very sure in what is the size of the int data type in your compiler, and irrespective of where your code is going to compile, you can actually define the variable fixed to a data type. That is done with this declaration, like int 8. You restrict your int data type to 8 bit, 8 underscore t, int 16 underscore t, int 32 underscore t, and int 64 underscore t. So here int 16 underscore t means it defines 16 bit for one data. The memory of 2 bytes will be reserved for a 16 bit, and the memory of one single byte will be reserved for 8 bit data. So you can restrict in that way. That's how the declaration is made. So here is an example. You can just work out how this data type is going to be. So I have actually declared int 8, and has 8 bits is the name of the variable that I am defining, and the value is 12, and 16 is here, 32 is here, 64 is here. I'm just declaring the value, just print those values. So And whenever the number is hexadecimal, we don't use percentage d, we use percentage x. That's how the numbers are defined. And for this data types, we need to have std int.h for getting those, the values. So we can actually, this declaration required std int.h and stdio.h. So I guess this can be demonstrated in the, you can actually work out this. Let me move further. Unsigned integer. So that is for the signed, what is we use for int. If it is unsigned integer, we simply say u in unsigned int. Similar way it works out. And I already told you how the numbers are treated in signed or unsigned domain. Okay. So this is going to be an unsigned number, so no signed arithmetics can be implemented with this. Overflow in an integer. So whenever you declare a number as unsigned, okay, so if I'm going to add, it could be even for a signed arithmetic also, overflow can occur sometime. Because whenever you add two positive numbers and if the result exceeds the range, the number goes to the negative. So there you are going to get the overflow. Similarly, if you are adding something to the number which is maximum, and here is an example that I'm actually telling you. I mean, see, if I'm restricting my number to 8-bit, then obviously the maximum number is FF. That means 255. If I'm adding one, what happens? That is something interesting. So I supposed to get that, but I will not get it. So it is going to truncate the value to 8-bit only. We can actually see this particular program, how it works. Let's move back to the program here and let me just work out. So let me just open one simple application again called compiler editor here, and let me copy this code. Okay, I have this program here into main. So what I'm declaring is I'm just declaring this unsigned int 8 small number as 255, and I'm just adding +1 to it. Okay, and the answer is this percentage u I'm going to declare, and the number is small number +1. Okay, so let me see how this going to behave. I'm going to get 256 or something else. So let me run this code. Look at this here. I'm supposed to get the answer. Okay, let me put it to the run this. Okay, let me change it and run. Wait for a while. Let me check it again. Okay, let me check it over here. So I had an error here, 250, 25 I gave now. Let me run this. Standard out, I am getting 2. So 25 plus 1, okay, let me run this. So 25 plus 1, I am getting the answer as 26, that's fine. Now what about the 256 plus 1? Let me check it. 255 plus 1, here also I'll make it 255. Let me check it now. Run this again. is 256. So we are getting the answer as 256. Verify this. Okay, now let me put it in this way. I'm going to change the number to a result UNT. Now see, I'm getting the answer as 256 because I'm nowhere storing the answer. So it is just displayed over here. Now let me put it the number as result. I'm going to save my answer as result equal to small number plus 1, and I'm going to display result. Okay. If this is a case, the result is also an unsigned integer restricted to 8-bit. Now let me run this. You should get the answer as 0. So previously we got the answer as 256, now we got the answer as 0 because now I am restricting my memory to 8 bits. So the result is truncated to 8-bit value. So let me back. So this is how the overflow will occur. So 2's complement representation in signed integer. So let me look into this in the next video.